All right, welcome aboard. Today we're going to be talking about the least squares approximation. We're going to break it down BRNY style right now. So you're going to be given, let's say, a set of points here, x's and y's, 1, 1, 2, 1, 3, 2. And now remember, we're looking to solve for the error margin here, where ax minus y is equal to the error, because ax equal to y does not have a solution. So we just want to find the closest thing that we can get to a solution, and that's going to be our E. The formula for our least squares approximation is going to be A transpose times A inverted times A transpose Y. So in this case, based on the points that we were given, we're going to have X values here and Y values here. And in our formula, we need an A matrix and a Y matrix. So we're going to right away call our Y values 1, 1, 2. That's going to be our Y, 1, 1, 2. And we're going to put our X values 1, 2, 3 beside a column of ones. So now we have our A matrix and our Y matrix. Let's break it down. Step 1. Forget about this minus 1 for a second. Let's just solve A transpose A. So A transpose is this first matrix here, where we take the first column of A and we make it the first row. Then we take the second column of A and we make it the second row. So this is the transpose of A. This matrix here is just A, our original matrix. So let's go through it step by step. We've got a 2 by 3 matrix here, and we've got a 3 by 2 matrix here, which means our product is going to be a 2 by 2. All right, one step at a time. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 9 plus 4 plus 1, 14. 1 times 1 is 1. 2 times 1 is 2. 3 times 1 is 3. 3 plus 2 plus 1 is 6. We'll go to the second row. 1 times 1 is 1. 1 times 2 is 2. 1 times 3 is 3. 3 plus 2 plus 1 is 6. 1 times 1 is 1. 1 times 1 is 1. And 1 times 1 is 1. 1 plus 1 plus 1 is 3. So there's your ATA. Now let's go ahead and invert it with this minus 1. In order to do this, we need to carry out a 1 over determinant operation first. So let's go ahead and put our 1 over our determinant is going to be 14 times 3 minus 6 times 6. So that's all squared away right here. And then we need to invert our ATA matrix, which means 14 is going to 3, 3 is going to 14, boom, boom. And then my other two entries are getting a negative sign in front of them. 14 times 3 minus 6 times 6 is 6. The 1 carries over, and then we'll just take our inverted matrix and set it here. So now we have ATA inverse here. Step 3, let's grab ATY. So remember, AT was just this matrix here, and Y was this matrix over here. So if we check these out, we've got a 2 by 3 here, and we've got a 3 by 1 here, which means we're going to get a 2 by 1 for an answer. Let's go through it. 1 times 1 is 1. 2 times 1 is 2. 3 times 2 is 6. 6 plus 2 is 8. 8 plus 1 is 9. 1 times 1 is 1. 1 times 1 is 1. And 1 times 2 is 2. 2 plus 1 plus 1 is 4. So here is your ATY. Now let's put it all together. ATA inverse from step 2 and ATY from step 3. So this just carries on right down here in the same form, and now we will multiply it by our ATY, which was this one here. I like to leave the fraction on the outside for the meantime. Let's go ahead and do the operation here. 3 times 9 plus negative 6 times 4. 3 times 9 plus negative 6 times 4. Negative 6 times 9 plus 14 times 4. Negative 6 times 9 plus 14 times 4. And we still leave our 1/6 on the outside because we haven't done anything with it yet. 3 times 9 is 27. Negative 6 times 4 is negative 24. Negative 6 times 9 is negative 54. And 14 times 4 is 56. Still retaining our 1/6 on the outside. 27 plus negative 24 is 3. Negative 54 plus 56 is 2. And we still have our 1/6. Now we'll distribute our 1/6 into our matrix here. So 1/6 times 3 is 3 over 6. And 1/6 times 2 is 2 over 6. We can go ahead and reduce these to a simpler form. 3 over 6 is 1/2. 2 over 6 is 1/3. X star, which is our optimal solution for this setup. Final answer, 1/2, 1/3. And that's the inverse squares BRNY style.